Okay, hello everybody. Some students had requested to know what's going on with the exam, which is coming up. So this is a short video that is hopefully going to explain how the exam is going to work and what you need to know. Since we're behind by a day, I'm going to be spending Monday's class catching up rather than reviewing as normal. So this video is going to take the place of sort of what I would have done during that class, which is to explain what you need to know from each section. I will also be posting a practice exam for you guys to work on, and then I will post a solution video to the practice exam on the YouTube channel later on. So first of all, let's go ahead and jump in on these sections, and I'll explain kind of what each one of them is talking about. So section 2.3 was, oh yeah, I should also remind you, the exam is on Wednesday, October 21st from 9 a.m. to 9 p.m. Same format as last time. You'll have the day to do your work, and then you will be required to scan your work and submit it on Blackboard as a PDF. You're not to work with any other person or any other resource. However, you may use your own handwritten class notes, and you may refer to the lecture videos on my YouTube channel, and you may refer to the textbook. Those are the only resources that you are allowed to use. Okay, so 2.3 was on interpretations of the derivative. So one main thing that you should know from this chapter is, so know, how to, make sure my microphone's right. Yeah, it is. Okay. Know how to interpret the derivative in the context of a word problem. Again, most of the problems on the exam are going to be word problems, so I would really make sure that you know how to do this. Okay, so that's one thing that you need to know from this chapter. You also need to know how to do tangent line approximation using the formula t of x equals, well, is approximately, let me back up. F of x is approximately t of x, where t of x is given by the equation f of a plus f prime of a times x minus a. Remember, this is just point slope form. It's the line, the equation of the tangent line. Okay, so know how to do tangent line approximation. That's pretty much it for 2.3. Okay, 2.4. Know how to find the second derivative and what the second derivative can tell us about the first derivative and the original function. So remember, second derivative tells us about whether or not the derivative function is increasing or decreasing. That can also be interpreted as telling us whether or not our original function, f, is concave up or concave down. pretty much all of 2.4. Okay, 2.5, you should know. Connection between derivatives and cost / revenue / profit functions. Namely, C prime of Q is the marginal cost. ... meaning R prime of Q is the marginal revenue, pi prime of Q is the marginal profit. One thing that you should also know is that the derivative of the profit function pi of Q is equal to R of Q, R prime of Q, minus C prime of Q. And this is just a consequence of the sum rule, sum and difference rule. If we have a difference of two functions, then the derivative of the difference is the difference of the derivatives. Okay, you should also know if pi prime of Q is larger than 0, we should increase production. That means that if Q increases, then profit will increase, which is great. So we should increase Q, in other words, the number of items we're producing, so that we can increase profit. And if pi prime of Q is less than 0, that's bad. All right, that's 2.5. So next up is 3.1. So this is getting into derivative rules. So 3.1, we should know sum difference rule, what else should we know? Derivative of a constant rule, multiplication by constant rule, should know how to find the derivative of a linear function. And we should know the power rule. Okay. So 3.2, we just learned more rules. We should know e to the kx rule. We should definitely know a to the x rule. We should know the ln rule. Yeah, those are the rules that we learned in that one. I guess that was a kind of a short one, huh? Okay. So next up, 3.3, we should know the chain rule and how to use it. We should also know how to use chain rule twice on a composition of more than two functions. And I'm going to edit this. This shouldn't say twice. I'm going to change this. I'm going to make this say multiple times. So we might have to use it 3 times on a composition of 4 functions. So multiple times. On a composition of more than 2 functions. Yeah, that's what you should know from that chapter. There's a little bit more to go into that in terms of you should know how to identify inside and outside functions. That's good to know. All right, for 3.4, you should know product, rule, and how to use it, / when to use it. We should also know the quotient rule and how to use it / when to use it. I'd recommend memorizing. My tip is to memorize low D high minus high D low over low squared. That's my tip for remembering that stuff. So that means derivative of the bottom function multiplied by the derivative of the top, subtract, do the derivative of the bottom function and multiply by the regular top. And then we divide by the regular bottom function squared. Okay, that's the tip for memorizing that, but you can use any mnemonic device that you like. So let's see, we skipped 3.5. So all of chapter 4 will be covered on the exam, unless there's a 4.5. Let me see here. There's a 4.5. 4.5, 6, 7 will not be covered. We'll cover 4.1 through 4.4, which is all we're going to do in chapter 4. So 4.1, what we should know is definition of a critical point. We should know how to tell if a critical point is a local max, local min, or neither. We should know how to do that. We should know how to do this thing using one of 2 methods. First derivative test, that's the one we do with the number line. And the second derivative test. Okay, so first derivative test, we check and see, does the derivative go from being positive to being negative? If it does that, then we're going to have a max. If the derivative goes from being negative to being positive, then we have a minimum. For the second derivative, we want to check if f double prime is larger than 0 at that point, then we're going to have a minimum. If f double prime is less than 0, we're going to have a maximum. And if f double prime equals 0, then we're not sure what's going on. Okay? 4.2 told us a little bit more about what's going on if f double prime is equal to 0. It means that that point may be a candidate for an inflection point. So no definition of an inflection point. You should know f double prime equals to 0 or f double prime does not exist at P means P, x equals P, is a candidate for an inflection point. In particular, f double prime equals to 0 or does not exist is a necessary but not sufficient condition for us to have an inflection point at x equals b. Okay, what else should we know about that? That's pretty much it. Okay, 4.3. So we haven't gotten into this yet, but we will soon. No, given a closed interval, a comma b, I want you to know how to find the global maximum and global minimum on, let me say, of a function f of x on the interval a to b. Okay, so for example, I have some function like this. Here's b, and here's a. The global maximum will be the very highest that this graph ever gets, whereas these points illustrated in red are local maximums, but not global maximums. Okay, so this green point is our global maximum. What else for that section? That's pretty much it. Just finding global mins and global maxes. For 4.4, know how to apply 4.1, 4.2, and 4.3 to cost, revenue, and profit functions. So, we want to know how we can maximize profits. We want to know how we can minimize costs. These processes are done by finding local and global maximums and minimums of the cost function, revenue function, and profit functions. And that's it. That'll be what is on your exam. So this is kind of not a comprehensive list, but this is a general guide for what you should know for this exam. You should also know everything from exam 1. So, exam 2 will build on exam 1. The focus of the questions on the second exam will be on the material that is in sections 2.3 through 4.4. However, many of these questions may require an understanding of the material covered on exam 1. Math has that unfortunate nature that it's sort of cumulative. So if you never really learned some of the stuff that we did for exam 1, I recommend coming to office hours or going to the SI sessions or going to the Math Tutoring Center or reviewing the book, which can be found on Wiley Plus, and you can do practice problems on Wiley Plus, review homeworks, check the homeworks that you did badly on, find your weaknesses, work on your weaknesses, and if you're confused about anything, feel free to send me an email. If you can't make it to office hours, we can set up an appointment outside of that. Just email me, say, hey, can you meet at this time on this day? If I can, I'll do it. If not, we'll reschedule some other time. So these are the things that are going to be covered on the exam. I hope to put the practice exam up soon. Good luck studying and have a good day.